what I'm going to share with you is how, and I'll tell you who at the end is actually doing this, but how to pretty much completely bulletproof your Kanban system if you have one. Or if you don't have one, how to set it up correctly. And the idea here is to avoid surprises with your Kanban system. And one thing we hear actually over the years, we've heard relatively often from people is, gee, we tried to set up Kanban, but it didn't work for us. There were too many problems, things getting lost, we didn't have the discipline, or whatever excuse, people can come up with to say why their Kanban system didn't work. But hopefully in this presentation, you're going to understand clearly what is required to really get it to work well. And this is actually being done. So it's not just theory, it's actual practice. So let's get started. So agenda for this webinar. By the way, I should introduce myself quickly if you don't know me already. Many of you do. I'm Richard Rahn. I'm the founder and principal with Leonardo Group Americas. We're a small, say, boutique lean consulting company, and our specialty at Leonardo Group is what we call line design, specifically mixed model line design and mixed model material delivery or material management. So those two areas are what we specialize in. And by mixed model, we mean environments where you have a lot of different products that are similar, but have different options or different features or different sizes, but they're pretty similar and they have to run down the same line. And unless you do that properly, then you can run into issues with inefficiencies, delays, blockage, material delivery challenges when you're going from one model to another, et cetera. So that's our area of specialty in the realm of lean. Okay, so with that agenda for this webinar, we're going to introduce the concept of Kanban, but quite briefly. So I'm kind of assuming that you know what Kanban is, but I didn't want to assume that completely. So we'll have a quick definition for you of what that is. And then we'll go through the sort of a generic Kanban replenishment cycle, how Kanban is supposed to work, starting with the point of use and then how a signal gets communicated back to the replenishment points and then back to the point of use or workstation. So we'll go through that. And then we're going to talk about some baseline assumptions, because there's more than one way to, if you'll pardon the expression, skin a cat. More than one way to set up a Kanban system. So I'm going to go through some assumptions that I'll be making in terms of how this is set up, some of the rules for this Kanban system. And then we're going to be doing what's called quick FMEA to each step in the Kanban replenishment process. By quick FMEA, by the way, if you're not familiar with FMEA, failure mode and effect analysis, you really need to learn this because it's super powerful and super important for anyone working in the lean environment. But I say quick FMEA because we're not going to get into trying to prioritize, which failure modes are more important or more risky, et cetera. We're going to assume that every failure mode needs to be addressed. So we're eliminating a big part of what's normally required with an FMEA by just identifying the failure modes and not worrying too much about the effects. We're assuming all the effects are bad. So we're giving them the same score, essentially. All right, and then I'll share at the end the case history of an actual company that is doing it the way I'm describing it. All right, so perfect. So let's launch Kanban definition. This image here of like a robot and a human is the image we're using for our Lean Sensei. So we've created an AI chatbot basically that has been trained in our information, our content, Leonardo Group Americas, mixed model manufacturing content. We've written quite a few books. So our books are, part of the training materials, and whatever else we thought was appropriate that we approved has our Leonardo stamp of approval. That's how our chatbot was trained. So I asked it to give us a definition, based on our own information. And this is what I got. So material Kanban is a lean manufacturing methodology that uses visual signals or triggers to efficiently control and optimize the flow of materials in production. Okay, so far so good. It centers on using those signals to manage inventory levels and coordinate material flow based on, here's the important point, actual consumption rather than pre-planned schedules like MRP. This pull-based system ensures that materials are replenished just in time, like pretty much just in time, not hand to mouth, but within a short time window, as needed, reducing excess stock and waste. Perfect. Various forms of Kanban, such as bins, cards, lights, electronic systems, can be used to signal the need for material replenishment, making a flexible and effective approach for maintaining smooth and efficient production processes. Wonderful. So that's our definition. Now we could spend a lot more time on talking about Kanban, but I'm going to move on here so you can dig into that on your own, I think. Now, before I go further, let me mention something. If this webinar is something of interest to you and the subject is something of interest to you, mixed model material management, we have a couple of training opportunities. I just wanted to mention it now instead of waiting till the end. On November 12th through the 14th, we have a workshop that we teach, but we are hosted by Toyota Material Handling. So it's in the Toyota Material Handling fork truck factory in Columbus, Indiana. And we've been doing this for quite a few years. So the next material flow workshop is on November 12th to the 14th. That may sound like a long way in the future, but it's filling up already, I can tell you. I think we have 10 seats remaining. So if this is something of interest to you, you could jump on it. I'll share with you well, Michael will share with us the URL that you can click on to find out more about it. And if you can't make it to Toyota, which is really an amazing life-changing experience, you can also take the same course on mixed model material flow online. We have a platform, our learning platform called Lean Design Studio, and you can find out more about that at leandesignstudio.com. So let's take a quick poll here. I'm going to launch this. And it's a poll for you all to share with us your experience with Kanban itself. And it looks like we have the results here. And I don't know if you can see this or not, but I'll tell you what. So all of you are somewhat familiar with Kanban. That's good. That's good news. No, but we're interested in learning more. 11%. Okay, that's a great opportunity for you if you haven't embraced it yet. And then 82%, 83% now, it just went up, are using Kanban apparently, but feel like there's room for improvement. And then 5% of you or now 10% are pretty confident that that's how you do things and it's working presumably pretty well for you. Okay, so that's good. We have most of you are in the sweet spot where you're using it, you know what Kanban is, and you're looking for ways to improve it. That's perfect. Okay, so here's the basic Kanban replenishment cycle. I'll start at the top, the purple box there. Trigger the need for replenishment. So this is going to be a signal of some kind. And the word Kanban literally means card or visual signal or signboard. So in the most classic Kanban methodology, it would be a paper card. And that card would be submitted or turned in to signal, hey, I need more of this. Now, why would you turn in the card? Well, you turned it in because you either used what you had or in a bin, or you started using what you had and you want to get going a little bit earlier on that replenishment so that you don't have to wait too long when that bin goes empty to get more. So we'll talk about that in a little bit more detail. So there's a signal or a trigger. Now, that signal doesn't have to be a paper card. It could be the bin itself could be the signal. Like the acro bin, with a label on it, that could be the signal, or it could be electronic Kanban, or it could be a light or some other, whatever you can dream up that would just provide communication or, send a message. So that's the first step. And then what happens is the signal needs to be communicated or delivered. So if it's a paper card, that paper card has to go, travel, be delivered to a department that's going to be in charge of refilling that order, basically, refill that container or the bin. So the cards presumably have to be picked up from somewhere out on the factory floor and delivered to what is usually what we call a supermarket area for refilling. Now, once it's delivered to that area, there are various things you can do with it, but I'm going to share with you the secret sauce of really making this bulletproof, and that is incorporating a scanning step here, if you don't have that already. So what I'm suggesting here is kind of similar to ballots, a paper ballot system or a mail-in ballot system where every ballot has an ID on it, has a barcode. So in this case, every Kanban card has an ID or barcode on it so that we can track it. So there's a step here that I'm going to explore in more detail here shortly about how that would work. And then we're going to validate the need for that replenishment. And if we need to replenish, we're going to actually reprint we're going to suggest that you reprint the card, right? Just a paper card. All right, so then what happens? So then that reprinted card, that new Kanban card, is the authorization to refill the bin. So that goes to the material handlers in the supermarket area. They're going to refill that bin or container or rack or whatever the conveyance method is that you're going to be using to deliver back to the point of use. And then you've got to physically bring that part back to the point of use, or the workstation, and put it where it needs to be, right? In a flow rack, ideally. So that pretty much completes the cycle. So that's it at a high level. But we're going to drill down on these steps here and explore not only what the step is in a little bit more detail, but then what could go wrong. That's basically what we're going to do. Go through this system and brainstorm, okay, if we deliver a card, what happens if that doesn't happen? What happens if the card gets lost, et cetera, right? All those gotchas, and explore what we could do then to error-proof the system. Now, here are the core assumptions that I'm making in terms of our hypothetical Kanban system. And they're not cast in bronze. You don't have to do it this way, but I'm going to try to make a case for why these steps are important or preferred. So the first one is paper Kanban cards. So this may seem antiquated. Like, why have a paper card as opposed to, say, an electronic signal, right, that can go instantaneously to the supermarket area? Well, the thinking here is that we want to engage our workforce. It's the lean principle of respect for people. So we want the operators on the line to understand their role in signaling and their partnership in the organization as an essential piece of this Kanban replenishment process. And so we're going to make it visual and physical, right? Have a physical paper card. You don't have to do it that way, but we're going to suggest that might be a good way to get everyone engaged so that people understand if you don't pick up the card and put it where it needs to go, that's going to be an issue, right? So everyone is paying attention, basically. Whereas if you were purely electronic, there's a tendency to not pay attention in the same way as picking up a physical card and putting it in a collection box, for example. Okay, so I think a strong case can be made for doing it that way. Second requirement, and you'll see why here again in a minute or two, is the need for an MRP system. And the reason I mention that is Kanban itself does not rely on forecasts or future demand or MRP types of calculations. It's simply, hey, I used what I have and I need more. But the issue here is that demand can change. Demand does change. And so demand for any particular item can be going up or down or stable. So how do we know that? Well, typically the way we know that is MRP. That's what MRP does. Material Requirements Planning System will take a bill of material and take demand or customer orders or forecasts and explode that out and give you a time-phased demand profile for every part. That's the heart of MRP. So that allows you to communicate with outside suppliers, but it also gives you visibility in terms of usage. If you don't know what you're using on a part, you can't really calculate Kanban quantities. So we're relying on MRP for that kind of information. So added that to the list. Again, I know not everyone has an MRP system or not everyone uses it well, but this is kind of part of the package. All right, next one, policy on when to signal. Now, for years and years, so if I'm an operator at the line, at what point do I actually submit the card or submit the signal? Or if I have an electronic Kanban, I click on the button on my screen. Well, there are a couple options. And what we taught for years and years in our lean practice was wait till the bin's empty, because that's a clear black and white point in time, right? So you're consuming a part out of a bin. You have more than one bin, but when the bin you're using is empty, that's the point in which you'd submit the signal or turn the whole bin in with a label on it. But what we've noticed over the years is some companies don't do it that way. What they do is they signal when the operator takes the first part out of a bin. So I have a brand new bin. Now I have other ones behind it, presumably, but I have a brand new bin. And when I take that first item out of the bin, I would submit the card. I would put the card in a collection location. Now, why are we doing it that way? Well, a couple advantages. One is you're going to signal sooner. If you signal, when you consume the first part, you're sending that signal back sooner than you would if you waited till it's empty. So clearly, that's going to be potentially helpful. You're not adding more cards to the system. You're just signaling sooner than you would otherwise if you waited till it was empty. So that's one potential advantage. The other thing is this. If you forget to take the card out of the bin or detach it from the bin and submit it when you took the first one, potentially when you take the second part out, oh, I was supposed to do that. Or the third part, I was supposed to do that. I forgot. Let me go submit it. If you're doing it ahead of time like that, then you have much less risk of not getting what you need, not getting that bin refilled. And also, if you wait till it's empty, then there's no reminder. The bin is gone, right? If you forgot to turn in the card and the bin is gone, what is it that's reminding you that you didn't do that? So the risk is higher again if you're waiting till it's empty. So our feeling these days is maybe doing it when you remove the first part is a better strategy, and that's what we're going to present here. Fourth requirement in setting up the Kanban system is custom software requirements. So I'm going to describe something that involves software to a certain extent. So we talk about manual cards and stuff, but I'm not talking about a 100% manual system here. So I'll be talking about some software requirements that maybe you don't have, right? So if you really want to bulletproof your system, you may want to have to think about developing some custom software. And maybe you can get ChatGPT to help you with that, writing the code. But it's not, I don't think it's complex and a complex software application, but it may be something you would need to have. And then finally, policy on the replenishment cycle. So what we're discussing here is what is our policy on how often we're going to be delivering parts back to the points of use. Now, again, this is something that's evolved over the years for us. What we originally were thinking and teaching was that you don't want to have a cycle that's too short because that's a lot of quote unquote non-value added material handling, right? When you have people delivering, in very small quantities to the factory floor and having to do that often. So the thinking was, well, maybe a half day, twice a day delivery schedule or something like that might be a better idea. But what we've seen with leading lean companies over the years is they don't do that. They maintain very low inventory levels on the factory floor, and they deliver often. So I say policy because it's up to you to decide. But the less frequent your deliveries, the bigger the inventory quantities you need to deliver for each delivery. So if you can deliver more frequently, then those inventory quantities are going to go down, right? And I'll share with you at the end what our case history company is doing. Okay, so I touched on quick FMEA already, but here's how it works. We're going to identify each step in the Kanban replenishment cycle. We're going to ask ourselves the question, what could go wrong? And then we're going to change or error-proof, poka-yoke that particular step with a way to, if not completely eliminate the possibility of error, at least really make it much stronger. That an error is going to either be caught right away or be repaired or not happen. Ideally not happen. And the difference is we're not considering the effects part of FMEA, the effect analysis. We're just assuming everything's important, right? Okay, so we're going to jump right into it here. So buckle your seatbelts. So I'm going to go through each step in a little bit more detail. So the first step is we're going to consume the first part. That's what I just described to you. So I'm at the workstation. I have a Kanban bin in front of me, and I'm taking the first part out of that bin. Again, that bin is not the only bin of this part. I may have others behind it on a flow rack, but I'm using the first part out of that bin. So when the operator begins to use parts, here's a description. When the operator begins to use parts for the first time from Kanban bin, there should be a Kanban card either attached to the bin in some way or another, or it's simply lying on top. And you take that card, the operator takes the card and puts it in a collection box. and that collection box should be nearby. So we're not asking the operator to do anything very difficult. We're not asking them to walk. Ideally, it's right there at their station, and they can just take the card and put it in the collection box. So the idea of adding a lot of motion or wasted time is something we want to avoid. Okay, so what could go wrong? Well, number one, the operator doesn't move the card to the collection box. They leave it in the bin. They forget. So what I just described earlier a minute ago is that can happen, but the operator will have an opportunity to self-correct or notice, right, that the card wasn't placed in the bin when they take the next part out. So at some time, hopefully in the near future. So if that's the case, then there's very little delay, and it should have minimal or zero impact on the Kanban system itself if they can recover the second time or the third time, etc. So that's an advantage of this. Second thing that can happen, there is no card in the bin, right? I'm taking the first part out, but there's no card. The card is missing. So in that case, we want the operator to alert, pull the and-on cord or push the and-on button, and have the supervisor or team leader take over basically and research, because that card needs to be reprinted basically. If there's no card, there's no signal, and that bin will not be signaled for refilling. So we don't want the operator to be distracted, but that is an issue that needs to be fixed. So typically the team leader would communicate that to production control, who's printing the Kanban cards, and that card would need to be put in there. Now, where's that card? Who knows, right? Could be on a floor somewhere in a trash can, who knows? Don't really care, but we need to have a card as a signal recreated or regenerated. All right, third thing that can happen is the operator removes the card but does not place it in the collection box. Now, why would they do that? I don't know, but maybe they got distracted, right? They took the card out and then some kind of thing drew their attention away, and they put the card in their pocket and forgot to put it in the collection box. That's perfectly possible, right? So basically now the card is lost, but there's no knowledge that it was lost, right? We don't know that it was lost. In number two, we know it was, or number one, we know, sorry, number two. In number two, we know it was lost, but in number three, we don't. So I'm going to describe to you what's going to happen here to flag those kind of issues. We're not going to know it now, but we're going to know it at a later step in the Kanban cycle. But that is a concern, right? Lost Kanban cards is, very common kind of complaint that people have. Cards always getting lost, misplaced, blah, blah, blah. So we do have a way of bulletproofing that, but not at this particular moment. Okay, next. Move the cards to a parent collection box. So here's the issue. We're typically organizing our team leaders, our groups, our teams into small physical areas. And presumably each operator will have their own collection box or have one that's close enough you can just reach over and put it in the collection box. So maybe it's shared, but worst case, every operator has their own little Kanban collection box. But those cards need to be gathered together and placed typically on the aisle where a material handler is going to come by during each delivery cycle. And as part of this delivery cycle, they're going to be delivering parts, they're going to be picking up empty containers, and they're going to be picking up the Kanban cards, right? So that material handler is not going to go roaming around the area picking up the cards. We want the team leader or the assistant team leader or the supervisor to be picking up those cards. So here's the description. The Kanban cards that were placed in collection boxes at or near the workstations will need to be collected and moved to a parent. So maybe it's a child box and a parent box, to a parent collection box for easy access for the material handler. And this will be the responsibility of the team leader or the supervisor and needs to be completed prior to the arrival of the material handler for each delivery cycle. So whatever your policy is on how many delivery cycles per day, it needs to be done before that, so the material handler can show up and the cards are there waiting. Now, here's where we get into some software that you probably don't have today. But the parent collection box will also include a signal to indicate that the cards are waiting for pickup and to communicate to a control board in production control, PC. So Here's how we propose that that works. Again, these are things you don't have, but could be important, right? So what could go wrong? Number one, the Kanban cards are not moved to the parent collection box. The team leader or the supervisor drops the ball and the cards don't make it to the collection box. All right, so how can we avoid that? Well, there's going to be a signal at the collection box, the parent box on the aisle, that's either on or off. When it's off, it means the cards are not there, right? The cards are not there waiting. That's what off means. When you turn the switch on, it means that maybe even a light goes on there. It means the cards are there waiting to be picked up. Now that signal on off is also going to be communicated, maybe wirelessly, maybe not, to a production control board where they can see each Kanban pickup area and whether or not that light is on. And so the job of production control then would be to monitor that. And prior to the launch of the next delivery cycle, they're going to want to look at that board. And the expectation is those lights are going to be on, right? Because those cards are there waiting for pickup. If those lights are off, that would be a trigger or a signal for production control to get on the phone. They know what the area is, call the team leader or call the supervisor and say, hey, we're about to launch the next delivery cycle. Where are your cards? And hopefully the team leader will then respond, right? Get the cards, put them in the collection box, and turn the light on. So that allows us, additional follow-up because we don't want production control, the tugger driver, to show up to pick up the cards and they're not there. Okay, so it allows us to follow up. Now, the other thing that can happen is number two, the Kanban cards are moved to the parent collection box, but the signal doesn't get turned on. So the team leader did their job, but they just forgot to turn the switch on. Well, that's less serious because the cards are there, but that will still trigger the same kind of follow-up from production control. And that'll be an easy one because the team leader will say, okay, I did it. I just forgot to turn on the switch. Okay, go turn it on and we're cool. So that's not going to slow anything down, but that will trigger the same kind of follow-up as before. Okay, so let me just take a quick look at chat. Are we all okay so far, folks? Everyone following along with the logic? And by the way, I said this before, but this is something that companies are doing, right? So I'm not describing some kind of brilliant idea that I thought of in my head. There are companies doing this to maintain their Kanban system. Okay, so move the cards to the box. So we're waiting for pickup. Now, next step, logically, the material handler picks up the cards. So what happens here? The material handler will pass by the parent collection box once every delivery cycle. How many delivery cycles? Up to you. The shorter the delivery cycle time, then the lower the inventory that you can manage. And probably the more easier it is to respond to anomalies if you're delivering more frequently. Okay, so then the material handler, typically driving a tugger, is going to pick up the waiting cards and turn off the signal. Okay, so the light goes out on the production control board, the light goes out at the pickup station, and we're ready for the next cycle. And the board is, the container is now empty. Doug, you have questions about the August workshop? Yeah, I can help with that as well. Okay. So what could go wrong with that? Well, material handler could forget to pick up the cards. Well, hopefully that doesn't happen too often, but if they happen to just drive right by, that light is going to stay on, right? And so again, production control is going to know, hey, during this cycle, the cards didn't get picked up at this location. And what would the answer? Well, maybe they have to send someone out there to get them, right? But ideally, it's part of the routine delivery cycle, so we don't have to make a special trip. But there will be a notification to production control that, hey, this light is still on. Or number two, material handler picks up the cards, but forgets to turn off the light. So again, this is kind of less serious, but that could happen. The light's going to remain on, and it's also going to be seen on the production control board. That should have been off. It's still on. What's going on, right? Call the team leader, have them come over and turn it off. Or number three, there are no cards waiting for pickup. So this is the only time this would happen is if there are no cards, right, that needed to be submitted. Now, if you're maintaining low inventories at the workstations, that should not happen very often. Could happen, but that would be unusual because you're consuming, material at a good rate, and those cards are going to be moving, fairly often. But if the material handler with the tugger sees that there are no cards to be picked up and everything else seems to be okay, just keep on going, right? Keep on making your deliveries and etc. But there's no real problem. But it would be highly unusual that would happen. Okay. So next, step 4, deliver parts to the scanning station. So now I'm the material handler driving the tugger, and I'm going to go around my route, and I'm going to come back and deliver these cards to the scanning, what I'm calling the scanning station. So material handler, upon completion of delivery cycle, drop off any collected Kanban cards to the scanning station for processing. And I'm suggesting here the cards are placed in a dedicated drop-off location for that delivery route. You may only have one delivery route. Okay, that makes it easy. But in many cases, you'll have more than one delivery route. And so we want to deliver those to a receiving box or a receiving location for that delivery route, so we can visually see if there are any missing, as opposed to just one big stack of cards. If no cards need processing during that cycle, we're also going to signal to the scanning area, hey, there were no cards. Now, again, this would be extremely rare. I don't know when this would ever happen. But if there are no cards to be processed, then there would be a none card or none signal in that collection location, just so there's no confusion from the scanning station. Hey, how come there are no cards here? Because if there are truly no cards and there's no none card, then that is a problem, right? Somehow they didn't make it back here. Okay, so what could go wrong? Material handler fails, forgets, or whatever to drop off the Kanban cards or a none card. Doesn't do either one of those. So then the drop-off location is going to be empty, and that is a flag that goes to production control for follow-up. Contact the tugger driver. What happened? Where are they? Human beings following up with their phones. Okay, so beautiful. So now the cards are at a scanning station. And this, again, is something probably new for you. So what happens here? Well, every Kanban card has a unique identifier, like a serial number or unique barcode. And as the cards are scanned, the part number that is scanned on that card is going to be analyzed electronically. So again, we have software involved here to determine if the card should be reprinted, held for some period of time, removed from the system, or whether an additional card needs to be printed, not just one, but two. And what this does for us is automate the process of Kanban maintenance, which is a big deal. I mean, you can set up a Kanban system, but over time, demand changes for those items. And therefore, the Kanban quantities, the number of bins that you may need to have for any given item, would change potentially. May stay the same, but it may go down or may go up. And if this is something we need to maintain, and we want to make it easy to maintain. So let's examine that. Let's explore that. So what could go wrong at the scanning step? Well, the card doesn't get scanned for whatever reason. So if the card doesn't get scanned, then in the system, the Kanban system we're contemplating, it's going to show as being at the workstation, right, at the point of use, still being used, still being active. So if the card's not scanned, it will show as still being in process. The software will flag this as a missing bin after some period of time. I'll talk about that in a minute. So if that card gets lost after it was turned in, essentially that's what we're saying, then it's going to get flagged, but maybe not at this precise moment. So I'll discuss that later. Second thing that can happen. When we analyze this card, what's going to happen is this. We're going to be looking at our MRP data. Remember, I said MRP will give us a time phase usage profile for every part. And that's what MRP does. The MRP logic will look at a bill of material, look at our demand, and kind of calculate out, right, what the usage is for different time slots. So what we're going to do is we're going to look into that system, the MRP system, output file, right, the usage file, if you want to call it that. And if that file is not current, then it's going to raise a flag. That's simply how old is, when was the last time we ran MRP? And if we have a rule in there that anything over a few days or a week is kind of out of date, then a flag will be raised, right? That's an easy thing to do. All right, number 3, what if the scanner fails, right? The scanner equipment that we're using, which ideally is like an automated scanner, right? You put the cards in there and it goes boop, 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 like processing ballots or something. If that piece of equipment fails, we need to have a backup plan. And so a simple backup plan, as long as I don't know what these things cost, but have 2 of them, right? Have a backup, have 2 scanners. And if one fails, you still got another one that you can use. There may be a third backup way of entering the information manually. That's something you could consider as well. I didn't put that on there, but that's something worth thinking about. What else could go wrong? Number 4, new Kanban cards that don't get printed. So remember, we're not recycling these cards. We're going to print fresh cards, but if for whatever reason a card does not get reprinted, then no signal is going to be going to the supermarket, and that bin is not going to be refilled. What will happen then is the number of bins, not the number of theoretical cards, but the number of bins will be lower than planned. And what could happen is you could actually run out. So the number of bins, is something we're going to calculate and monitor, and it's going to be flagged on the line as well. The quantities that we have are too low. And again, this in terms of FMEA, the effects analysis, the probability of that happening is low. But we're trying to think of everything. And then finally, we're printing out new cards. So if the printer that's printing out our new cards fails, again, same issue. We need to have a backup printer somewhere. So if it's not another printer at that location, it's at least another printer somewhere in the plant that we can send those files to be printed. So we need to have a backup plan, basically, if the printer fails. All right, so far so good. Now here's the electronic Kanban validation process. I'm going to go into this in a little more detail, because this is really the secret sauce of this entire webinar. This is kind of the secret sauce for managing your Kanban system, and not having to do like a big maintenance project, because you're going to be doing it every time you scan a card, automating the Kanban maintenance process. So here's what happens. The card is scanned in for a specific part number, and the MRP database of future demand, like time phrase demand, is going to be accessed. And what we're going to be looking for is, basically what we're going to be doing here at this step is recalculating the number of bins. The Kanban formula is very simple, right? But we're looking at future demand. If that demand changes, it could change the number of bins that we would normally want to have. In either direction. It could be that we need more bins or fewer bins. So we're going to get that from the MRP system. We're going to do a recalculation of the number of bins. Now, if the number of bins changes, we have some decision rules we're going to apply, or if it's the same. So I added those here. So first example is, well, we currently have 4 bins. We're talking about an individual item, right? Some item. We currently have 4 bins, and the recalculated quantity is 3. So what's going to happen is that card that we just submitted and scanned is not going to be printed, right? We're taking a card and a bin out of the system. So no replenishment signal is going to go back to the supermarket area. That will not be refilled, right? So that's one possibility. Second possibility, the current number of bins is 4. The calculated number of bins is still 4, didn't change. So we're going to reprint that card. It's going to go to the supermarket area for refilling, and then for delivery back to the point of use. Okay, that's probably the most common scenario. And then the third scenario is we calculate, the current number of bins is 4, we calculate 5. So in that case, when we print this card, we're going to print 2 of them. And the supermarket is going to return to the point of use 2 bins instead of the 1. That's because we see in MRP, we see demand going up for that particular component or part, right? Got it? So I guess what I'm saying here is what I just told you. If demand's going up, then additional card may be printed. Demand going down, the card may be removed or paused. So this is custom software. I don't think it's that difficult. What do I know, right? I don't have to do it, but I don't think it's that difficult. But it's applying some rules and it's making adjustments to your Kanban system on a real-time basis. So this is incredibly powerful. If you've had to deal with maintaining a Kanban system, you'll appreciate this. But I think it's perfectly possible. But it does require you to have that information available on future demand, and that's typically available in an MRP system. All right. Patrick is asking, what format are the additional software for scanning and monitoring modified bandana capability in ERP custom program? I don't know. Like that would be beyond my pay grade. But I am describing to you these systems do exist, right? So I'm sorry I can't answer that exactly. I'm just thinking there needs to be some kind of custom module that does that work, right? That takes the scanned part number, is able to read that MRP data, apply some rules, and provide a recommendation, right? Provide an action. Okay, so we're now at step 6, automated audit process. So this again is something that's a little bit different. Again, it might involve some customization, which I don't think is complicated, but here we go. So when a card is printed, it's assigned an expiration date, like a container of milk, right? A use by date kind of thing. And this is a date and a time when the card is expected to complete the cycle and be returned to the scanning station. So that time is an estimate of the time it's going to take to go through the entire replenishment process, get used on the line, cards pulled, and it comes back to the scanning station. How long should that be? And of course, the more frequent you deliver to those workstations, then the shorter that time is potentially going to be. But it's an estimated time. And what are we using that for? Well, if a card gets totally lost, right, misplaced, your dog ate it, we still have this expected date for that card. And if that card doesn't come back to the scanning station within that time, that raises a flag for production control. So if the expiration date expires and that card has not come back yet, production control and materials will need to physically conduct a search for that card and bin. This is literally someone going to look, right? Going to the station. That card should have come back. Where is it? And it might be that it's still at the station, in which case, okay, we answered the question. We still haven't answered the question, why didn't it come back sooner? Has demand changed for that part? What's going on there? But at least that's not really a problem. But there may be some other issues where the card is truly lost and the bin is not found. So this physical audit, I'm saying, may trigger an analysis of the Kanban cycle time if it is too short in the system. If you put in it's too short, then you're going to get a lot of like false positives where it should have come back, but it didn't. But then you go and you see it's still at the station. That's a case where some adjustments may need to be made. So what could go wrong? What if the date expires, but the bin is still in use? That's not really a problem, but it may trigger, as I just said, a review of the expiration date process. But number 2, what if the date expires and the bin can't be found, right? I can't find it. In that case, that's going to be a more in-depth audit of what happened to that. Okay? So let's see. Sorry, I just lost you there. Okay. So we do have then a warning signal that's built in based on a date. Okay, so step number 7. We're getting close to the end here. Don't worry. So step number 7, pick the parts and deliver. So at this point, the printed cards are delivered to the supply location, the supermarket, or locations. You may have more than one replenishment area. You may have one area for certain kinds of material, maybe a hardware replenishment area. Any kind of hardware item gets to get refilled in this area, or larger parts or electronic components, et cetera, are refilled from another area. That's perfectly possible. And what will happen is material handling is going to pick the parts and then fill the bins based on instructions on the Kanban card. Right? Look at the Kanban card. What do we need to do? What are the quantities? Hopefully the filling process is efficient. You don't have to count parts. You just fill the bin. But so whatever the instruction is on the card, bins will then be staged, ready for delivery. And then at some point, the material handler will get on the tugger and drive away with some wagons behind with those parts and start another delivery cycle. So a couple things that could go wrong here. What if the parts are delivered to the wrong location? So the material handler, everything's perfect except the material handler puts that bin in the wrong location. Well, again, if this is a serious concern, what you can do is you can have like a scan confirm that the location that bin is placed in is correct. In other words, a barcode on the rack, on the flow rack, you scan the card, scan the location, and get a go or no go. If that's in the right place. That is something you can do if that's truly a concern. Second thing that can happen is, what if the card back in the supermarket, they place the wrong card in a bin, or place, when they're placing the cards in the bin or attaching cards to the bins, they mix them up in some way or another. So you've got essentially the wrong parts in the bin based on the card. So this is going to be, you're going to find this out immediately at the workstation, because you're going to have a bin with the wrong part in it. And so, again, that would be an opportunity to pull the and-on cord and have the team leader come and fix it, basically. Work with production control. Again, this is not something we'd anticipate happening very often, but if it does, you're going to know right away, right? So you don't have to worry too much about that. Okay, so that's it. I mean, that's basically the entire process. So again, the new things that you may not have today is the ability to have an expiration date on the card, so you can do an automated kind of follow-up or raising flags if it doesn't come back. Second thing is this issue of checking for the quantities, the number of bins, and doing real-time maintenance of your Kanban system, which is incredibly powerful. And then the third thing is the cards waiting in the parent collection box, having a little signal there so we can make sure that everyone's doing their job and the cards are going to be ready. Because if they don't get picked up, then it's going to be a whole nother delivery cycle unless we take special action before they get picked up. So we have that system in place. Okay, so let's see. I'm looking at the chat here. Stephen, some ERP systems include electronic Kanban functionality. The vendor might be able to, yeah, that's exactly right. You might be able to get some help from the vendor. Again, we're not super big fans of 100% electronic Kanban. I've already talked about that issue already, but having systems are clearly involved in this kind of bulletproofing suggestion, right? How to bulletproof your system. So we'll cut to the chase here. The company that's actually doing this that I have most familiarity with is our friends at Toyota Material Handling in Columbus. So some of the characteristics of their Kanban system, which works extremely well, is this. They have a short delivery cycle. When I first saw this, I thought wildly short, wildly crazy, but I'm starting to appreciate the rationale for this. But they have a delivery cycle of 35 minutes or 12 deliveries per day, per shift. They only have one shift, so that's essentially per day, but 12 times per shift. So 35 minutes. Every 35 minutes, a tugger is going to come by, pick up the cards, deliver full containers, pick up empty containers every 35 minutes, which is, pretty amazing, I think. They are an MRP user. They're using SAP. So they do have access to that data. And whatever software they had, I have no knowledge of who developed it or how they did it. I think they have in-house, custom software that does what we just talked about in this webinar. They have that. They have 12 different delivery routes. So they're able to manage that, which is quite a few, right? But it's a pretty big factory. I think it's 1 million plus square feet. They have 3 different supermarket areas. So again, additional complexity. They have one for the hardware items that I mentioned. They have one for like intermediate sized parts, and they have one for imported parts. So 3 different physical areas that come together in a consolidation area to be loaded onto the tuggers. And then they have almost exclusive tugger delivery conveyance. There are a few exceptions, really big, heavy items. Engines, I think, are delivered on an AGV kind of cart. And the counterweights are huge and extremely heavy, delivered maybe fork trucks, I think. But basically everything else is delivered either on custom carts pulled by a tugger or just carts with, bins on the carts. So the end result then is, in terms of how this is performing for them, is number of line delays due to shortages where something didn't work in their Kanban system is like extremely rare. I don't remember, I'm sure it has to happen, but I don't remember really it being an issue or being discussed at all in the many times that I visited this factory. Okay, so guarantee it is being done. It's not impossible. So lessons learned in this webinar. We're reaching the end here. Error-proofing a Kanban system is necessary, since what happens when you have a leak, that's what you see in this little weird Dolly, AI image. When you have a leak, it has serious repercussions. Ideally, not ideally, potentially stopping the line. So chances are good that to really get to this level of error-proofing or bulletproofing, you may need to develop custom systems and tools, like we just talked about. ChatGPT can write code for you. I don't know if that's an option, but anyway, that's up to you, right? That's not what we do. You may also need to staff up in certain areas. Like I kept talking about team leaders doing this, supervisors doing that, production control, checking this, et cetera. Well, those are humans, right, doing that. So when something happens, there needs to be a response. Not tomorrow, right? Not in a few hours. People need, it's like, in an emergency room, people need to come running. And so you need to have the people available to do that. So this whole strategy may require some rethinking in terms of your staffing. And then finally, if you move in this direction, don't forget about training everyone, down from the operator on the line who needs to understand their role in picking the card up and putting it in a bin, to production control, to everyone involved, right? Needs to understand how this whole system works and their role in making it work successfully. But again, we do have success stories in this happening. All right, so that's it. So I'm done. Yes, but let me, before you leave, let me tell you a little bit about this. We have 2 workshops at Toyota, same place I just talked about, this year. One is mixed model line design on August 6th through the 8th. Now, the subject there, someone was asking about that. Was it Doug? Yeah, Doug. So the subject matter at line design is workflow design. So workflow is what we're talking about when we talk about tack time and standard work and line balancing and simulation modeling and physical line design, all those issues, flexing. There are a whole host of issues that are discussed. And it's a 3-day class at the Toyota factory. And while we don't claim to be spokespeople for the Toyota production system, basically what we're talking about is kind of what you would see. And there are 2 factory tours. So this is how Toyota Material Handling, who, by the way, is the industry leader in North America for fork trucks and has been for the last 24 years. This is how the big boys, run their factory. So that's on August 6th to the 8th. It is about 2/3 full already, sold out. 2/3 sold out already. So again, if this is something of interest, you can go to this URL here, Mixed Model Line Design at the Lean Design Studio, and find out more about the agenda, what happens on each day, what are all the topics that are covered. And then we have in November the material flow class. That's more aligned with what we were talking about in this webinar on November 12th to the 14th. Again, it's about 2/3 sold already. So even though it's far away, there seems to be interest. So basically the same format where we talk about, instead of workflow, we're talking about material flow. So plan for every part, setting up a Kanban system like we've discussed in this webinar. The other various delivery methodologies, sequencing, kitting, all the different strategies for getting the parts to where they need to go. Supplier Kanban and supply chain discussions, conveyance, batching, again, a whole list of subjects that you can see at this link here, leandesignstudio.com, mixed model material flow. Right, so both of these classes are like the two wings of the bird. So if you're a lean specialist, you really need to know both. But it's really an amazing experience. No one in the last 14 years has gone to these classes at Toyota and said, "This really sucks. I knew all this already, right? I didn't learn anything." No, it's kind of like the opposite, right? So, eye-opening experience. It's a lot of fun as well. It's just amazing experience. So if you can pull it off, that's well worth it to give yourself that 3 days in the mothership, right? Seeing how things work. It'll stay with you the rest of your career, right? The rest of your career, whether you're a manufacturing engineer or a material flow specialist, it'll stay with you the rest of your career. Okay. Doug, I'll get back to you on the, you already signed up. Okay, I'll get back to you on the access to the Lean Design Studio. I think you sent me an email too. I'll see that. Tony Rodriguez says, just the plant tour is worth it. Okay, so that's it. Thank you, Tony. You've been there, right? I know. You're testifying to it with your own eyes. Again, so thanks for your participation. I think this was a really important topic, this webinar. And so if you start going down this road, let me know if we can help, or just share with me your success stories. Love to hear about it. And if there are my email addresses here. If there's any other questions you want to ask me, just to go ahead and reach out. With that, I will let you go. Get back to work.